Hello and welcome to lesson 8b on logarithmic functions as inverses. A logarithm equation is actually the inverse of an exponential equation. They're very closely related. So you've probably seen this button in your calculator. It says the word log, right? We've seen that button in our calculator. Well, a log is written as log with a base of b of a equals x. Now, what that means actually is this can be converted back into an exponential function where b to the x equals a. Note the b stays the base on both. The a goes from one side of the equal sign to the other, and the x becomes your exponent. Just remember, guys, what a logarithm actually does is it asks, given a base b with an answer of a, what did I have to raise b to get a? I had to raise it to x. A logarithm finds an exponent. That's what it does. So let's just practice real quick rewriting these exponents in logarithmic form. So if I have 9 to the 1/2 equals 3, I could write that as a log, as log base 9 of 3 is 1/2. So 9 to the what gets me 3? 9 to the 1/2 gets me 3. Or this guy, log base 5 of 1/5 equals -1. 5 to the what gets me 1/5? Well, 5 to the -1 gets me 1/5. Now let's go backwards. Let's rewrite these logs as exponents. So log base 2 of 8 is x. Well, 2 to the x equals 8 is how I'd write it as a exponent. And log base 3 of x is -4. Well, 3 to the -4 is x. We actually could go ahead and solve those two if we wanted to, but we're going to learn about solving here in the next step. So now, let's take a minute and actually solve some equations. In order to find the value of a logarithm, I'm going to first set it equal to x, then rewrite it as an exponential, then evaluate. So log base 2 of 32, I'm going to set it equal to x, and I'm going to rewrite it as a logarithm. 2 to the x is 32. Well, that really is asking 2 to the what gets me 32. Well, I could rewrite the 32 as 2 to the 5th. I'm sorry, guys, I've already made a little mistake here. That should be, that's 2 to the x. So 2 to the x equals 2 to the 5th. Therefore, x must equal 5 for that to be true. Log base 3 of 81 set equal to x. That means 3 to the x equals 81. Well, 3 to the what gets me 81? 3 to the 4th gets me 81, so my x value was 4. Log base 4 of 4 set it equal to x. That means I'm going to do 4 to the x equals 4. Well, there's a hidden 1 right here that I don't have to write. That means my x is 1. Log base 5 of 1 set it equal to x. Rewrite it as an exponential equation. 5 to the x equals 1. Well, in order to get anything to an exponent to equal 1, my exponent must be 0. That's the same thing saying as 5 to the x equals 5 to the 0. Therefore, my x value is 0. Log base 6 of 1/6, set it equal to x. Rewrite it as an exponential equation. 6 to the x equals 1/6. Well, I'm going to rewrite the other side as a base 6. That's 6 to the -1 to get 1/6. Therefore, my x value must be -1. 2 to the what gets me 1/16. Well, that would be 2 to the x equals 1/16. I'm going to rewrite both in base 2. So 2 to the x equals, well, that's going to be 2 to the 4th is 1/16. So 2 to the 4th is 16. So 2 to the -4th is 1/16. Therefore, your x must be -4. So all we're asking here is what would I have to raise the base to get the thing inside the logarithm? That's what the x value is. So moving right along, we have log base 9 of 3. I'm going to set that equal to x. So 9 to the x equals 3. I'm going to rewrite both of these now in base 3. This is 3 to the 2x equals 3 to the 1. I can now drop my bases to say that 2x equals 1. Therefore, my x value is 1/2. And if you think about this guy, 9, the square root of 9 is 3, and the square root is the same thing as taking an exponent of a half. So 9 to the 1/2 would get me 3, so my x value is 1/2. Let's do something similar here. Let's set that equal to x. I'm going to say 6 to the x equals root 36. Well, guys, simplify root 36. 6 to the x equals 6. Well, there's a hidden 1 here that I don't have to write, but is there. Therefore, my x value is 1. Log base 5 of the 4th root of 5, set it equal to x, rewrite it as an exponent, 5 to the x equals the 4th root of 5. I'm going to rewrite the 4th root as an exponent, so I get 5 to the x equals 5 to the 1/4. Therefore, my x value must be 1/4. Log base 1/3 of 27, set it equal to x. So I have 1/3 to the x equals 27. I'm going to rewrite both of those in base 3. 1/3 is the same thing as 3 to the negative 1. Keep in mind, guys, it's still being multiplied by the exponent of x. And 27 is 3 cubed. So now I'm able to drop the bases and say negative x equals 3. So that means that x must equal negative 3 on that problem. Log base 1/2 of 16. I'm going to go through and set that equal to x and rewrite it as an exponential equation. 1/2 to the x is equal to 16. Rewrite both in base 2. 1/2 is 2 to the negative 1. That's still got the x exponent that I haven't dealt with yet, is equal to 16 is 2 to the 4th. We can now drop the bases and say negative x must equal 4. Therefore, x must be negative 4. Let's do L. Log base 1/5 of 5, set it equal to x. I'm going to do 1/5 to the x is equal to 5. Rewrite both in base 5. This is 1/5 is 5 to the negative 1. We still have the x exponent there, is equal to 5 to the 1. Therefore, negative x must equal 1. Therefore, x is in fact negative 1. Now let's take a look at this guy. Log base 9 of root 3. Set it equal to x. I'm going to say 9 to the x equals square root of 3. I'm going to rewrite both of those in base 3. 9 is 3 squared. We still have the x hanging on there, right? And then the square root of 3 is the same thing as 3 to the 1/2. So now we can drop the bases. 2x equals 1/2. I'm going to divide both sides by 2 to get that my x value must be 1/4. And let's take a look then at my last one here. Log base 5 of 5 root 5 equals x. So that's, I'm going to rewrite that as an exponent. 5 to the x equals 5 root 5. I want to rewrite this where they're both in base 5. This guy is 5 times 5 to the 1/2. Or combining those by adding their exponents, that's 5 to the 3/2. And we still have 5 to the x on this side. And at this point, you can drop the bases and you can just say that x is 3/2. All right, so to solve an equation with logs, we're going to rewrite them in exponential form. So log base x of 25 equals 2. Rewrite it. This time, my base is x. This is x squared equals 25. So to solve this, and remember, log's only defined for positive bases, so when I take the square root, I don't keep the negative. So my answer is just x equals 5 after I root both sides. Let's take a look at this one. Log base x of 4 equals 2/3. Well, I'm going to transform this into an exponential. X to the 2/3 is equal to 4. In order for me to get rid of that exponent, I'm actually going to raise both sides to the 3/2, raise it to the 3/2 to clear the exponent. So I get x equals, that's the same thing as the square root of 4 cubed, or 2 cubed, which is 8. So my x value is 8. Now we have log base 1/4 of x equals 3. So switch it into exponential form. 1/4 cubed equals x. Well, I can cube top and bottom. I get 1/4 cubed is 64 is equal to x. So that would be my answer. Log base 4 of x equals -2. I'm going to flip it into exponential form. 4 to the -2 equals x. Well, 4 to the -2 is 1/16. That must be my value of x. All right, if a log has no base specified, it is understood to be of base 10. This is called the common logarithm. So if I write log without writing a base, it's understood that the base is 10. So log of 1,000 is really, I could rewrite that as log base 10 of 1,000. And I'm always going to set them equal to x to solve. So that's going to be 10 to the what gets me 1,000. Well, 10 cubed, so my x must be 3. 10 cubed gets me 1,000. Same thing here. Log of 1/10, that's really log base 10 of 1/10, and I'm going to set that equal to x. So I have 10 to the x equals 1/10. Well, that means my x value must be -1 because 10 to the -1 gets me 1/10. All right, down here we're going to find each value. Again, we're setting these equal to x. So 2 to the x equals 16. Well, 16 is the same thing as 2 to the 4th. Therefore, my x value is 4. This one's a little bit different because now I've got 2 log of 2 to the 16th. And if you notice, we just solved log base 2 of 16 to be 4. Therefore, 2 log base 2 of 16, I can exchange out this piece here to make that 2 to the 4th, which is just 4. Whoa, no, back that up. It's not 4. 2 to the 4th is 16. So that was my answer. 2 to the 4th, 2 to the log base 2 of 16 is 16. Now let's look at this guy. Log base 3 of 1/9, I'm going to solve it, set it equal to x. So I'm going to flip it into exponential. 3 to the x equals 1/9. Well, 3 to the x equals 3 to the -2. Therefore, my x must be -2. That means this piece is the equivalent of -2. Well, 3 to the log base 3 of 1/9, let's solve that. Just like before, this piece here is here again, so we could rewrite this as 3 to the -2, and guys, 3 to the -2 is just 1/9. And if you notice, guys, these are of a very similar pattern. They both have an exponent raised to a log of the same base, and the answer always ends up being whatever you're taking the log of, right? So to generalize, b to the log base b of x is equal to x, and log base b of b to the x is equal to x. So those are 2 shortcut laws for you that can help you out in the future. So let's do these. If I have 4 to the log base 4 of 5, because I've got the same bases here and here, I know my answer is the 5. Short and sweet. So 6, log base 6 of 2, again, these bases match. So my answer is whatever we're taking the log of inside there. My answer is 2. And then if I've got log base 3 of 3 to the 7th, these guys match. My answer is going to be the 7. And the reason for that is that, and then right here we've got log base 5 of 5 to the -3. My answer is going to be that -3. So let's take a look at this then. Log base 9 of 3, we could solve this by setting it equal to x, but you could also recognize that 3, it could also be written as log base 9 of 9 to the 1/2. Because the square root of 9 is 3, it's another way to get there. That means that my answer here is going to end up being the 1/2. And log base 8 of 2, well, you could also recognize that 2 is the same thing as 8 to the 1/3, because the third root of 8 is 2. So my answer here ends up just being the 1/3. And log base 32 of 2, well, we know that 2 to the 5th is 32, so log base 32 of 32 to the 1/5 is this 1/5. is the same thing as 2, therefore my answer here is 1/5. These are all just shortcuts that we could use. And log base 16 of 64, this is one actually that, because there's a lot going on here, I'm going to go ahead and do this the old-fashioned way by saying that equal to x, where this becomes 16 to the x equals 64. I'm going to write both in base 4, I think. So this becomes 4 squared is 16. We're still multiplying by that x exponent, equals 4 to the third. And so I end up with 2x is equal to 3, so x is 3 over 2. All right. So at this point, guys, you're at your practice for this. Go ahead, try it out. If you do not have your unit guide, or if you aren't able to print out your unit guide, you can work these on a separate sheet of paper. Just be sure, guys, don't forget to do your annotations, even if you're doing them on a separate sheet of paper. If you're using this page, that's fine. You can just print out the annotations there. But thank you guys so much and have a lovely day.